What is the essence of science? Ask an impertinent question, and you are on the way to the pertinent answer. The Ig Nobel Prize for Physics in 2016 was awarded to Gábor Horváth, Miklós Blahó, György Kriska, Ramón Hegedüs, Balázs Gerics, Róbert Farkas, Susanne Åkesson, Péter Malik, and Hansruedi Wildermuth, a group of researchers from Hungary, Spain, Sweden, and Switzerland, for discovering why dragonflies are fatally attracted to black tombstones. Dragonflies are strongly associated with water because their larvae are aquatic. After emergence, the young dragonflies generally leave the water during their maturation period and return for reproduction. For most species, water bodies with visible surfaces are places where the sexes encounter each other and where females oviposit. This group of researchers sought out to investigate why dragonflies of various Sympetrum species were attracted by particular black gravestones, at which they displayed the same behavior as at water surfaces. It has been shown that some dragonfly species are polarotactic, that is, they detect water by means of the horizontally polarized light reflected from the surface. Therefore, they can be deceived by any surface with similar polarization features. The behavior of both sexes of the dragonflies is governed by feeding or mating. Mature males that took up sites at dark gray or black gravestones were probably mainly seeking mates, as they clearly exhibited reproductive behavior, although they were feeding, too. On the other hand, immature individuals, and possibly also mature females, used the perches for basking and feeding only. Ectothermic dragonflies, for thermoregulatory reasons, usually prefer sunlit places. Jerzitsa and Corman observed that females in tandem pairs of Sympetrum oviposited onto nearly horizontal glass panes in a botanic garden. The shiny black plastic sheet, similar to the reflection polarization characteristics of the horizontal parts of shiny black gravestones, was much more attractive to dragonflies than the other test surfaces. The Sympetrum species observed are polarotactic, as are many other aquatic insects. Polarimetric imaging measurements and double-choice experiments demonstrated the following physical and physiological reasons for the attraction of dragonflies to dark gray or black tombstones. These Sympetrum species possess positive polarataxis, that is, they detect water by means of horizontally polarized reflected light, and only polished dark gray or black gravestones reflect strongly and horizontally polarized light. If Sympetrum dragonflies can choose between a strongly and horizontally polarizing surface and a weakly and non-horizontally polarizing one, they always prefer the former. Hence, the insects defended their site more intensely if the chosen perch was on a shiny black plastic sheet. According to polarimetric measurements, the degree of linear polarization of reflected light is higher the smoother and/or the cleaner the surface of the gravestone. Horizontal surfaces reflecting light with a higher polarization value were more attractive to polarotactic dragonflies than less polarizing surfaces. The same is true for polarotactic aquatic beetles, water bugs, and mayflies. This explains why Sympetrum individuals were most often attracted to black gravestones with smooth, polished, and clean surfaces. Although their reflection polarization characteristics depend on the illumination conditions, the horizontal surfaces of both sunlit and shaded black tombstones always reflect horizontally polarized light. Another reason may be that perches near a gravestone in the open are more likely to be sunlit than those under trees. Want to discover more interesting scientific research? Search Ig Nobel Prize series to find more information.